So as a first participation, we tried to make it simple. So we took hydrogen as the only energy vector. There is no battery on board. There is no solar panel. Only hydrogen. We tried to keep the features as simple as possible. Well, basically because we didn't have much data, so we tried to make it as simple as we could to keep control of the engineering. We tried to recycle as much as possible as well, and we used 3D printing for fast prototyping, and notably for the propellers. We also tried to keep the pilot in the loops during the trials. We had the chance to have the hulls and we were able to do some trials at sea starting May. So. And overall, we think of this boat and this challenge as a platform, as an educational platform to train the students in the long run on a new project, a new engineering project, and we will probably focus in the future on the 3D printing, for instance. Oh. Okay, so conception methods on design. So as I said, we have only one source of energy, hydrogen, fuel cells, and we worked also on the design of the propeller with some fluid mechanics computation. So we have a 5 kilowatt fuel cell system developed by the Symbio Academy. So 2 young engineers from Symbio were trained during this process of designing the fuel cells. We use also 2 reservoirs from Advanta. We modified the controller of the Torqeedo engine to adapt it to the fuel cells capabilities, and we worked extensively with La Ferme 3D to 3D print propellers with specific characteristics. So here are some pictures of the production process. As you can see, we went quite raw in terms of materials for the structures. It's basically made of aluminum, which was reused from other projects, and we used some carbon-charged PET for the propeller to 3D print it. One of the main challenges for us was to keep control of the weight. So at a whole, the energy system is about 85 kilograms, something like this, so which it's quite heavy. We also struggled to get data. I'll come back to this to design to fit the fuel cells to the engine, and we also struggled to design and to find the appropriate printing process for the propellers. So the first challenge for us was to be able to get the data from the engine so that we could fit and design the fuel cells to fuel directly the engine. There is no battery in the middle, I insist on this. So it's a challenge to stabilize everything. It still is, actually, for us. Initially, we designed a kind of bench test, but after, very quickly, we faced a voltage surge, which destroyed the controller. So we were basically with no data for a while, and we decided to change the controller, create a new one, and then to go directly at sea to get data on real life. It was also an opportunity to test the propeller directly in real condition. This is a short overview of the design process of the controller, of the propeller. As you can see, this was about 3 weeks ago. We were really not sure of being able to achieve the correct 3D printing, but I think the end result is quite beautiful, and actually it was tested after the race by Uniboat, and it's pretty cool, and it gives a way forward, which is pretty interesting. Just quick word on the look of the boat, which is a bit, at least some people notice. We started with this to do the test at sea. It's a very simple platform of aluminum with battery packs and pretty ugly. So when our designer looked at this, he thought that we were joking with the design, and so he proposed to actually do a kind of camouflage inspired from the boat of the World War II. So he ended up with the design in blue on top, but of course the jury was not really happy about the camouflage, and the principle was to be quite visible, so we ended up with a compromise, which is this orange one. And I will finish this with about the name of the boat. It's called Calou 1, Calou the First. It's dedicated to François Pascal Nérac, who was researcher at one of the lab in our site, and he died a few weeks before the challenge. So we expect to have Calou the second next year, and to have a long dynasty of Calou. Well, regarding the environmental impact, it's about 60 kilograms of aluminium, 1 kilogram of H2 consumption, and I take this opportunity to thank all the team who helped us with the hydrogen. It started with the SBM, which literally saved us for the event like 2 days ago, because we had an issue with filling our old bottles, and they really kindly lend us a bottle, and which was actually filled with solar panels in the harbor. And not later than a few minutes ago, the Portuguese team from Technico actually took his bottle from the boat and lent it to us, so that we could try to take the last start. So we really thank them. Sorry? From Portuguese, sorry? Oh, we got yes. Well, actually, everybody helped us with hydrogen, basically because we are not able to refuel our to refill our bottles. Well, actually, we were also contributing to their project, because we 3D printed a couple of devices and parts for other teams. So for the test, we used 4 batteries, but then on the boat there is none. Okay, in terms of eco-design, we favor second life materials. Actually, it's a second-hand Torpedo motor and we changed most of the device inside. The aluminium comes from cutting waste from our workshop. There is very little electronics on board, very little pilot display, and we use recyclable materials for the propeller. Well, about the innovation, at least the attempts that we had for this project. So we have a specific cooling system for the fuel cells. So we take there is literally a pipe in the water, so it's a cooling system with water. I cannot say it's a full success, because initially it was mounted inside the engine, but we are facing a couple of troubles with the circulation of the water around. So we decided at the end to move it on the side, but then of course we are creating more drag. So I cannot say it's fully stable as a system. One of the main features is that we have a direct connection from the fuel cell to the engine. This was quite challenging, and it still is, because we still have some surge, and sometimes the engine or the fuel cell actually is not really delivering full capacity to the engine. And we have this specific printing process for the propeller. This being said, I will go quickly on this, and I will let the specialist answer to your question probably more in depth. I will say that Symbio is it's a fast-growing company on H2 and fuel cells, and our partner was the Symbio Academy. So it's a kind of training branch of Symbio where you have the new engineer coming through to test new things. And then La Ferme 3D is thinking about going at scale and is exploring, thanks to this event, possibilities to create specific propellers for boats, for yachts, and also maybe to create some onboard factories for yachts, so you could change and quickly print spare parts. Okay, thank you for your attention.
Thanks, Min Energy Challenge. Jury members, do you have any questions?
Merci. Thank you. Congratulations for your project. You mentioned a few times that you 3D printed a specific propeller. I'm trying to understand what's specific about it, and also you mentioned at the end something interesting about La Ferme doing like customized, tailor-made propeller. Would you have an idea of what does that mean? What is the link, and what are the type of customization and link to the boat specifics they can do?
So I will let people from La Ferme answer for the second part, but as for the first part, basically, well, if you look at the original propeller, which is provided by Torqeedo with the engine, it's about 25 something centimeters of diameter. This one is like about 50% more. So on really the ratio of the propeller is about the diameter. It's also the surface, which is much bigger. So we fitted it for the endurance course. Ideally, we could have printed much like some other propellers for the speed, for etc. We simply didn't have time since the process was not yet fully stabilized. It came stabilized very lately, but now it is. So now we can really envisage to have many more applications on more specific propellers. As for the future usage of this in the yachting, maybe you want to answer to this, or? So I'll keep going. So we are discussing actually together about adaptation. Typically, you have some, if you imagine a yacht which is going at sea for months in a very remote places, which broke, and then you have not a critical piece, but one of the pieces which is quite difficult to get in few days, then maybe you can imagine to 3D print it. It's actually what we did when we came to the yacht club to have the stand with the printer on top. The furniture was broken, so we simply 3D printed the parts to repair the furniture and then to be able to 3D print the propeller. So it's actually pretty efficient as a process for pieces which are not so critical, but you are pretty sure that they will break and they might impair your project, your travel for a couple of days.
I do have a question, in fact, two questions. One is a big link to what Florestan asked you about. Have you considered the strength of the 3D printing for the propeller, because it looked like you had so many breaks during the trail that everyone had, so that's why we know that we can make the test at least at a very low speed for the 3D printing, but most of the time what you want to have a lot of torque, you are a bit limited. So that was my first. And second question will be a bit more about you are a very good team of hydrogen, and I am a bit interested in having exactly the details that you can share with the other team if they want to develop hydrogen vessel. What will be your advice? Because you take an option that was very risky and also interesting by saying that I want to take out the batteries. I want directly to connect the fuel cell directly connected to the engine, but that for sure give you some limits. So could you go a bit in these details? Because that might be one of the most interesting parts for the other team.
Okay, so I'll answer for the propellers and Christian will answer for the cells. For the propeller, yes, we did some strength tests. Actually, the first computation comes from the fluid mechanics, and then we adjust the design, and we have a couple of 3D printing tips. And we actually modified the process so to make sure, and we reinforced the structure, etc. I cannot tell you everything about the process because we would like to keep it for a while just to move on with it. But yes, of course, it's not directly the computation of coming from the fluid mechanics which provides us the end result. There is some enhancing of this design to take into account definitely the resistance. At the end, we are pretty happy. We didn't destroy anything during the whole. Actually, since we are testing them, the last 3 weeks, over 3 weeks, we had quite an extent experience of navigation with 0 damage. So we are pretty happy about it. But it's about the printing process and the way we modify the result from the fluid mechanics to make it resistant enough. Now, for the fuel cells, pass the floor to Christian.
Thank you. First of all, I would like to say that, as Sébastien mentioned, this is a research project for us also, and a project that we want to share with the students. So in the years to come, we will try to improve the system, trying to solve some problems we had during this session, and we hope we'll have a better system next year and the years after. We had some innovative actions for the systems, for sure. First of all, we wanted, or I said we, but it is the engineers from Symbio who proposed us to cool the system with seawater instead of having an air water cooling system. So this was the first innovation we wanted to test here. So as Sébastien mentioned, we had some difficulties because it's very critical where you pump the water too close from the propeller. We had some issues because probably some air came into the pipe and the system was not cooled down efficiently, so we have to change the position. But at the end, it was okay. We had a little bit of more drag, but we could cool the system down. So this was the first innovation, and the second one, which is maybe more interesting, and this is the one that you mentioned. There is the fuel cell is directly connected to the motor, and the issue here is that our motor, as all the Torqeedo motors, I think the people used here, they have a very short range of voltage. And we could not do that with the controller, which was initially in the Torqeedo motor. So since it's a second-hand motor, we had no fear with the warranty. So we could change it a little bit, add our own controller, and this allowed us to power the motor with a different voltage. And it could adapt then to the voltage delivered by the fuel cell, because the problem with the fuel cell is that the voltage is changing with the current and with the power that is delivered. So this was the innovation, and we were really not sure at the beginning it would work. We had some problem, as Sébastien said, with the controller, and at the end it was a chance, because since this controller was damaged, we could change it. I mean, the Torqeedo controller was damaged, so we took the initiative to change it, instead of changing the full motor. And it was at the end a chance because we could directly connect the fuel cell to the motor.
Thank you. And would you be okay to share these details, specific details, with other team? If we're going to have in the future other participants that want to participate with hydrogen energy, would you be okay to open this exchange, or it has to be closed?
I think the idea and the spirit here is to exchange with, this is the spirit we have in the school and the research center, so it's to exchange with our students, with all the participants here, but to give a clear answer and a definitive answer, I think we have to discuss with the engineers of Symbio, because I'm not pretty sure about the intellectual property which can be behind this. But for sure, the idea is to share.
Yeah, no, but thank you for the answer, but I think that's mandatory because the future of the voting might be close connected between us by the management of the fuel cell, the engine, the batteries, what kind of batteries, what kind of management. And if this event have to come out with a solution, it might be one of these solutions that is definitely one of the most important for the future of the yachting. Do we have other questions? Okay, we have one question behind that.
Yeah, behind the main room, another question for you.
Sorry, I was a bit late. But what was the impact on the dynamism of the motor control? Because you are using direct fuel cell, so the fuel cell is a bit slower to give the full torque to the engine. So the control of the fuel cell might be an issue. How do you manage that without the battery, in fact?
Actually, the key was the control of the compressor and making sure that the compressor answers quickly enough to avoid starvation when you have a big demand for current. So we use tables to be sure to answer very quickly.
Okay, and congratulations for what you. I'm sorry, we have another question, I guess.
Oh, it wasn't.
It's
sorry.
okay.
No, I believe.
Congratulations, thank you for that. And if they want to ask me if they have to share, I am at the disposal. Thank you.
Applause, please. Open source for the Tech Talks. And now I call on the stage Technico Solar Boat Energy. There are two projects, solar one, hydrogen one. And we are listening to you. You have 7 minutes to present your project.
So, hello everyone, my name is João Novo and I'm the team leader for Technico Solar Boat. We are here for the first time in two classes, the solar class as usual with our third prototype, and for the first time with the hydrogen vessel that you can see right here. So, we are from Portugal and we are students of engineering at one of the top university of engineering in the country. We come from the various fields of engineering, from chemical engineering to aerospace to electrical and so forth. The team leaders are those named here, and we are a total of 70 people working alongside on both boats. In this hydrogen boat, we took a different approach. We were curious on how could we apply more ecological components and materials and composites without compromising the efficiency, reliability, and the strength of the hull. So instead of doing that with our solar prototype, we venture on into the hydrogen, as asked us also by Jeremy. And so we did. We took the mold and reuse of a former student team from our university. We had to fix it because it was quite damaged, but nonetheless, it was more or less wasteful than rebuilding a new one. We also used flax fiber instead of carbon fiber, and we'll explain later the difference in terms of ecological impact on the different fibers. And for the Portuguese touch, we finished with some cork in some of the components of the vessel. The system is composed of only a fuel cell. It's our own only source of energy, the hydrogen. And it has a 5 kilowatt torpedo motor and all the graphic interface and data logging as the solar prototype. So this is what we ended up with, but as the flax fiber had such a nice look, we decided, although it was a dull color, not allowed in the regulations, we decided to stick with it, and I think everyone appreciates it. About the conception, this is not a boat because a typical boat we don't have to produce a hull and have into account all the variables that we have in the account in the solar prototype. So we just did some simple analysis and some distribution of weight to make sure that we could sail safely. This is for testing the stability of the cockpit with the floaters underneath. About the production, it took us around 6 months. The budget was much lower than the solar prototype. As I've said, it's from flax fiber with a PET core, a recyclable PET core, and it uses the same bio-based resin from Saint-Gobain that another team also uses. It has some issues, this fiber, because besides the properties, which are way more bad than the carbon fiber, it is a very absorbent fiber, so it took a lot of resin, and we had to make measures to not weight so much, and we did so. About testing. Testing was a lit on a hurry. It's our first prototype. The systems have been tested and started being tested 1 month ago in total with all the sensors. And there was no water test because we couldn't manage to find floaters or time. And there was no load test because we had some issues at the end and we couldn't even manage to put a column on a barrel of water to have some load to the fuel cell. So this yesterday or the day before, I don't recall, was the first time we put the boat on the water and we did pass inspection. So it was a great victory for our team. In terms of the carbon fiber versus flax fiber, the difference is abysmal. The amount of energy to use for the same properties, because we are assuming that we can achieve not on all fronts, but on the ones that count to us the same properties with double the weight of the carbon. The energy expended is way less. So we did reuse the cockpit mold, we used natural fibers with the flax fiber, we used the recyclable PET core and the bio-based resin from Saint-Gobain. And as we've said 1 year ago, we are also testing our own electrolysis system because the end goal is to produce a completely green cycle of production of hydrogen and consumption of hydrogen, and therefore get out of the fossil fuels production or subcomponent that the hydrogen comes from or is reutilized. So this is one of our pieces, the full process from the core to the lamination. And that's all. Thank you for staying with me, and I hope you enjoyed, and feel free to ask some questions.
And I'm sure you will have some questions. From jury member first.
Thank you again. Obrigado. And just to interesting comparison you made on carbon fiber and flax fiber. Could you go more into detail of how you calculated the energy wasted for both?
The data is based on the webinar hosted by the Yacht Club 1 year ago in the COVID pandemic, the chaotic COVID starting pandemic. And it was presented by Herman Grossman. So that's where we sourced it from.
Okay, but then let's say, did you guys look into it a bit? What would you have to tell everybody about, you know, the energy consumption of both? What would you have to say about it?
From the start, the fiber is not a natural one, so it's not compostable. or biodegradable, and the refinement of the carbon fiber produces a lot of waste and a lot of carbon to the atmosphere. So.
Thank you and congratulations, because you are quite amazing team in the solar class, and you take the challenge by changing for the energy class, because I advise you that maybe the hydrogen might be a good evolution for your future employment, and I hope you are happy about it now. I used to take the technical solar boat as an example, because you were one of the first pushing the open source. So, and I did not see there too much open source dedicated into the hydrogen. Could you please give us a bit more details about the technology you used, why the hydrogen, what was the pressure, 200 bars, why you did not want to go for higher pressure, and if your experience will be able to be shared with the other team for the next year, because we are all sure that we're going to have more and more hydrogen vessels in the future. And if you want to make a strong evolution, we need to have this experience shared with the other one.
Yeah, we have a shared vision of the concept of open source. In terms of the system itself, I'm calling to stage the main leader of that area, and is outside, so someone went picking him up. But the system is going to be open source as far as everything besides the fuel cell, because we signed a confidentially agreement so that we could use or have the fuel cell for our case. He's actually here, so I'll give him the microphone so he can.
Hi. So maybe I could ask you to repeat the question, please, because meanwhile.
You was not in the tech talk room.
Sorry?
You were not in the tech talk room.
No, actually I was here, but he was too nervous and couldn't see me.
No worries. No, the question is, I most of the time take you as an example about the open source and sharing the innovation, sharing your data, sharing all your development in order to help all the other team to increase their level. And this is what we all want. We want to be smarter all together. So could you give some example details about the hydrogen propulsion, and where and how you want to share this as an open source platform as you used to do every year?
Yes. So I think the approach will be the same that has been discussed, yeah, we'll keep on that straight line, because actually one of the hardest part of building this system was gathering information. We had no idea how to do it. And our approach, I mean, I've been told all my life, if you don't know what you're doing, surround yourself with people that know. And so we try to find always at least 3 feedbacks from people, from different companies, different engineers, through LinkedIn, through emails. And it was a hard part of the process. So it took 6 months just to get a fuel cell, and then 6 months to validate what we were proposing. And definitely after this, we'll go home, we'll check the data, we'll have a correct fuel cell efficiency, and we'll provide everything on our open source platform.
Thank you. And if you have to do, and I'm sure maybe not, but I trust you're going to come back next year, what will be the plan in order to optimize the boat?
Yes, so definitely we have to lose some weight. For example, we have a DC-DC converter that we might not need. We were checking with Mines. They were very helpful. Thank you, man. He was telling us how to lose the DC-DC. We have a VASC who can use it, so that will be the first approach. And then we have to increase the power of the motor. Our fuel cell gives 5 kilowatts, and we can even get out half of that to our electrical motor. So those are the 2 main approaches.
Yeah, this is where I want to go, because when I made my calculation, when we write the rules, my idea was that you might have a specific propeller for the long distance race, but I was expecting more an average power of the engine around 10 kilowatts.
Yeah.
And I was a bit surprised just seeing 5 kilowatt engine.
Yeah,
So
yeah, that's correct. I mean, it was the motor we had. As John said, we had a low budget, and we struggled through the whole process to try to keep it low. And yeah, let's see next year.
okay, just one advice that you can share with the other team. The idea behind that when we designed it was helping you to maybe have a second life, second usage about the engine used on the solar class, because most of them are in between 6 to 10 kilowatt with a very good shaft. So that might be an idea for you.
The engine is actually one of our old engines from the solar class. The column is a Torqeedo column in second hand from one of our sponsors in the previous years. The throttle also it came from them. So most of the components we either try to find them in second hand or someone that doesn't no longer need it, or we're trying to fix something that has been broken and can be fixed for a lower price and a lower cost for the environment.
Perfect. Do we have some question in the room? It looks good. Thank you, gentlemen, and congratulations.
Well, let me just take the opportunity. Sorry, I've told you this before in the conference we had in our university. I was finishing my course. I didn't know what to do really, and I'd like to thank you again for pushing the hydrogen in TSB, because it completely changed my life, and I know this is it for me for the future. Thank you very much.
Whoa! Congratulations and thanks for your words. And now for the next Tech Talk, please come to the stage. I call to the stage Innova. Innova, with your applause. 7 minutes on stage. Is there someone for Innova? Chloe, Zayeb, maybe, or someone else? For Innova. Yes. Maybe is it possible to have the sound outside to call them? Chloe, or someone from Innova for the Tech Talk now, please. And if there is nobody, 1, 2, 3. We're waiting for you, Innova, for the Tech Talk. And the next, if there is no Innova, it's Anne Solar. Oh, Innova is coming. You have 7 minutes for your Tech Talk about your tender of 12 meters. You can have a microphone over there. For the Ask Camille, but
Ah non, il les a changés à l'instant, il y a eu des erreurs dessus. C'est pour ça. C'est moi. Je te laisse parler. Tu me laisses parler.
today, Innova in the Endurance Challenge with Tenderworks, we won the Endurance Challenge. Let's go for Innova. Waiting for your slides.
Waiting for the slide. Good afternoon, everyone. I'm sorry I'm not Chloé Zayed. Everyone must be disappointed. Unfortunately, she's not available, so I had to jump in to replace her last minute. And I'm with Ben, who will answer probably most of the technical questions. But he was not so confident in his English, so that's why he asked me to join him. So to talk about Innova, the project started about 3 years ago, and it's actually the dream of Chloé Zayed, who founded the company about 1.5 years ago now. So she started working on that project initially because she couldn't find a solution to have a zero-emission boat that would bring her and her passengers to explore the Calanque de Cassis, which is a natural reserve. And so she was looking for a proper solution that would give her enough range to be able to navigate these waters for a day, when all she could find was with limited batteries range. And so she decided to turn to hydrogen as an alternative solution to extend the range of the boat. Of course, at that time, there was nothing available on the market. And so she had to start looking for solutions and work on developing solutions with the right partners. And these partners happened to be EODev. EODev, a company that was the spin-off of the Energy Observer project. So it's like when you say that planets align. And so the combination of the developments made by EODev and Chloe's dream of being able to have a fully zero-emission boat to bring her passengers to explore these natural reserves gave birth to the Innova 40 as the first prototype of what will become a production boat by next year. So this is actually the prototype. So this prototype is a 40-footer, and it is based on an existing hull that was designed by Gilles Vaton, a well-known French naval architect. The fuel cell that powers it is installed and developed by EODev in collaboration with Toyota. It's actually the stack that equips the Toyota Mirai, the first generation of the Toyota Mirai. The next vessel will be equipped with the new generation, with the new Toyota Mirai fuel cell and the new range extender by EODev. Capacity, it's got 3 tanks, 3 hexagon type 4 tanks, hydrogen tanks at 350 bar pressure. Each contains 7.5 kilograms of hydrogen when compressed at 350 bars. And I insist on that because, for example, during the races and the race today, the endurance race, the boat was only at half its capacity because we could not refuel 350 bars in Monaco. And in fact, in none of the stopovers of each of the seashore stopovers, as the boat went from Marseille to Monaco, because it was using a truck and the high cube system to refuel, and we could only get 200 bars. So with 200 bars, you basically get about 65% of the total weight that's available. So in this instance, there was between 13 to 14 kilos of hydrogen on board. And that's why the boat ended up doing only 12 laps when it could technically have done 24 laps if filled up. So, but normally the tanks is 350 bars, total 22.5 kilos. And it's got 2 electric engines of 220 kilowatts each. And it's combined with 3 batteries of 44 kilowatt hours that were developed by a sister company of EODev called F-System. Basically, these batteries are certified marine use battery, LifePort technology, rather than the standard LMC. And the idea with this boat is to have the combination of the benefits of batteries and the benefits of hydrogen. If she were to have the use profile with only batteries, the boat wouldn't cruise, it would sink, would be too heavy. So when you have this combination, and these calculations were made by the EODev engineers, defining the relevant profile, the use profile, and configuring the boat with the 3 tanks, 1 fuel cell, and 3 batteries. Of course, other combinations are possible. It all depends on what you want to do with your boat and what's the range that you expect, what's the speed that you expect to achieve, And in this instance, the idea was to be able to have a 12 knots working speed, cruising speed, but possibly reach up to 25 knots at max speed. So combining the power of the fuel cell and the power of the batteries. What's worth knowing is that if you run only on the batteries, you will be able to reach 18 knots. And if you run only on the fuel cell, you reach 10 knots. So you can see that with the combination of the two, this is where you get your power to be able to reach 25 knots. But that's not the objective. The objective is to optimize the working speed at 12 knots. And that's what the boat does. You have the details of the various elements and who was involved in the development process. I've already mentioned, I think, most of it. One of the things that was especially developed by EODev was the cooling system, which will actually be integrated into the next generation of the range extender Rex H2. Because at the moment it's separate, but with the next generation, which is more compact, has got a bit more power, then it will be integrated, so it has to have a plug-and-play solution. Some information about the production. What is interesting is that everything took longer than expected. As I would say as usual, but you know, you always think that it will be easy, and it's not that easy. And this has nothing to do with the fact that it's a hydrogen and battery-powered boat. It's just that you end up facing small things that make it complicated. And I'll give you a very interesting, well, we don't have a video of that, but one of the first or one of the last issues we had with the boat is the fact that everything worked perfectly well. And when we did the testing, suddenly after 12 knots, the boat, the engines, the electric engines started resonating because the silent blocks were not the right size. Obviously, this was not expected, but that did bring issues because it had to be dismantled and the engines had to be worked upon, silent blocks change, in order to be able to have a proper running boat. So these are small things, but the addition of these small things delays everything. Of course, on top of that, you've got COVID, restrictions and everything, delayed in transportation of parts, and that makes life difficult. But the end result is that the boat is here at the Boat Challenge, and I believe that most of you would have seen it, and it's met with quite a big interest. So it works perfectly. Ultimately, it works perfectly. Everything was done in the Palombo shipyard in Marseille, and well, basically for about a year. At the end of the boat's life, you've got some information about what is intended to do. I mean, the fact that this prototype should have been fitted with foils is not the case. No time to do it to be able to be here for the challenge. But then there will be foils on the hull. It was prepared for it to save 25% consumption. Yeah, basically, that's about what needs to be said. The important thing about that is when you save on consumption, obviously, the calculations show that you can remove one of the batteries. And so if you remove one of the batteries for the same performance, you save on tons of CO2, about 3,000 kilos of CO2. At the moment, it's a prototype based on an existing hull, but the final boat will be based. Sorry? Pour finir. Okay, next. Next. I've already talked about that. Forget that. You know it all. So the first special feature, well, it's actually the first hydrogen-powered recreational boat that has been homologated, certified CE for recreational use. I think that's quite outstanding as an achievement. And Chloe should be congratulated for opening that road. Thank you. You've got plenty of questions.
Congratulations. and I was actually wondering about the hull design because I thought, you know, so much hard work has been put into this boat. It looked pretty conventional to me, at least. So I'm wondering, you talked about foiling. I'm wondering if there's other, whether it's on the hull design or on the hull raw materials, what are, apart from foils, what are the things you're looking forward to doing?
Okay, on this one is indeed a conventional hull, is an existing hull. And what's good about it is that it's taught us a lot of things to be able to optimize the next version, the proper production boat, which will be, in terms of the use of the materials for the hull, will be eco-conceived. And when it comes out, you'll see it's a very different hull shape, actually. But that will be for next year's Energy Boat Challenge. On this one, it's really about the propulsion system. We're keeping it as a surprise. You'll be able to see it come September, where the boat attends the Cannes and Monaco yacht shows. But the real finished product, you'll see it at the next Energy Boat Challenge. This year is really about the propulsion system and the combination of batteries and range extender.
Good afternoon. Congratulations for this great achievement. I have a question regarding regulations on homologations. I know it's been a struggle all the way along. In a nutshell, can you tell us a bit more about that?
Okay. The class society classification society we work with was BV, and the range extender in this case is a case approval, so it's not type approval yet. Type approval will be on the new generation because the ODEV is working on having type approval for generation 2 of the range extender. So it's only case approval on this one. With BV, and the next one will be also with the NV to get type approval. And to get the homologation, I must say there was a bit of a trick, because what happens is, given the lack of updated regulations when it comes to the use of hydrogen on board vessels, your primary source of power is not hydrogen. So to get the homologation, the primary source of power is in fact the batteries. Okay, that was in a way the trick to make sure that the homologation could go through. But we're certainly hopeful that things will change in the near future. Does that answer your question? Yes.
Can we get some more details about order of magnitude? Budget. The budget.
No. It's a lot.
I'm talking about orders of magnitude.
It's a lot of money. It's a lot of money. It's a prototype, and the boat, this one first, is not on the market, and the next one will be on the market. But the price of the next one has not been finalized yet because the hull has not been finalized, the construction has not been finalized. We know roughly what it's going to be, but we don't know exactly, and I don't want to talk about it.
Okay, and is it going to be too challenging to ask who is supporting such an investment?
Same. You won't get the answer. It's private. One thing I can tell you is that it's all private money, and there's absolutely no support from any government agencies like ADEME, because whenever there are such projects that are put towards them to finance, there's always something that goes wrong.
So there is a jury member who changed the ranking because open sourcing is one of the issues. So you have been great in many things. You know, you've been giving many details and many answers, but I think that's something in terms of
It's open source for the technology, not for the budget. One thing I can tell you is that at the moment, unlike most boats, the price of technology would be roughly 50% of the total cost of the boat, which is massive when you compare with the diesel solution, obviously. Is that open source enough?
Not sure.
Thank you so much.
Jeremy Lagarig, jury chairman.
Do we have other question in the room? I do have one. So I know the project, and you know who I am as developing this propulsion, but we need to share with all the people how it is working. You say that as a homologation, it is the trick is an electric boat, and we are using the hydrogen on the range extender, but it is very important that everyone understand and share exactly the details. By the peak power, it is given by the batteries, and the average energy, it is given by the range extender. So could you share these details, because this is definitely keen for the designer, architect, and all the people that want to build a hydrogen vessel, especially the one close to me, but also to anyone in the room, to have the details about the energy consumption for example, today.
Okay, one of the initial, I would say, thoughts when developing the propulsion system was, and the idea, in fact, was that you would use the fuel cell for the continuous power, so at 60 kilowatt, so that would provide you, I mean, really continuous power. And I said earlier is that you can run at 10 knots when you use your fuel cell at 60 kilowatt. And that whenever you needed to have peak power demands, you would use the batteries as a combination with the fuel cell for peak shaving. The reality is that it's slightly different, because with the energy power management system developed by EODev, the objective is to optimize the consumption between the two systems. So when you think that it would make sense to simply have fuel cell for continuous power and peak shaving for the batteries, the state of charge of the batteries when it goes down means that then it's the fuel cell that's operating, and so it's always a balance between the two to optimize the consumption. And that's one of the key learnings, and something that obviously needs to be, I mean, will be worked further upon, I would say, to increase the artificial intelligence of the system. But one important aspect of that is that it's simple, in the sense that with that PMS, you don't have to worry about shifting from the fuel cell to the batteries. It's unlike, you know, when you have a diesel electric engine, for example, you're on diesel and then you need to shift to electric. And as we know, many captains won't even bother doing it. With our system, it's pretty simple. It's all managed by itself, as long as well, it depends on the power requirements you have. Does that answer the question?
Yes, yes, and one last, but very fast, because it is also important to share that. This one are lithium batteries, but LiPo batteries, but there is some other batteries that you can use on hydrogen depending on the usage. So could you share what kind of battery you need to use by different type of usage?
What I'm going to say on that is that we do use LiPo solution because it's very safe. It's recognized and validated by the class societies, and it's simply much safer than the standard LMC batteries. There's no thermal runaway, so you don't take a risk of ending up sinking your boat because of fire. It's pretty simple. And so even if the battery is heavier and less compact than other standards, it is definitely safer, and we would recommend anybody that actually puts batteries on the boat to go for LiPo technology.
Okay, I wanted to speak about the Titanat, but I think we are out of time. Thank you so much, and congratulations, and say hi to Chloe.
Thank you.
Congratulations to Innova, and now we came back with a solar class. I call on the stage Anne Solar Boat, solar class. Congratulations today for your championship race. And then you have 7 minutes to present your project on stage. And please respect the speakers and jury members in the end and the back of the main room. Please be quiet.
Well, good afternoon. We are the Dutch team Hans Solar Boat. We are telling our little story. My name is Jurian. I'm the owner of Q Concepts, one of the partners of the boat. My background is in yacht racing. Now it's solar boat racing. And this is...
Hi, my name is Mick, and I'm an electrical engineer to the solar boat team, and I'm a student at the Han University of Applied Sciences. Well, our team is based off a couple of students of the Han University. Some are a mechanical engineer or a product designer or embedded software engineer. And yeah.
Sorry, a little fight with a little remote, but first of all, well, we're from Holland. A little, some of the information about Holland, the highs and the lows. Our highest mountain is actually 322 meters. Our lowest point in the country is 7 meters below sea level. And the country itself is about 30% of the country is below sea level, so we know what it is to work with the sea. And the sea is a big part of our lives.
Yeah, so the Han University of Applied Sciences is one of the five biggest universities in the Netherlands. And as I said, our team is based off a couple of students. So a mechanical engineer, product designer, embedded software engineer, and like myself, an electrical engineer.
Yeah, about the boat and the concept of the boat. The boat itself is based around the monohull concept. It features 2 contra-rotating propellers, which is at the moment pretty standard in our class. The boat itself is actually optimized for the near-shore conditions here in Monaco. We had some big crashes, especially the first day, but our boat has a little bit more freeboard than is strictly allowed. It has a lot of buoyancy, a lot of volume in the bow area, and we've chosen for a T-foil configuration because we think it's a configuration that is pretty easy to use to make the boat fly, but it also leaves a lot of potential when we switch from a mechanical height sensor, so a mechanical wand, to an electrical system. That's the reason why we've chosen for the T-foil configuration.
Yeah, so the university is all about designing methods, and 2 methods we use are the morphological overview and the castle ring method. In combination with this methods and 3D printing, it made us make fast prototyping and came fast through prediction.
Well, regarding production, well, this is our second boat that we have as a team. And we used some of the parts of the previous boat, especially the battery, for example, and the engine. We use recycled PET as a core material, as mentioned by our French friends as well. And when you look at the PCBs, which is more the cup of tea of Mick, we made a big set of custom-made PCBs, but we included 3D printed parts for spacers, for inserts, also on the PCBs. Well, problems. I think life of an engineer is about 50% problems, solving the problems. It's actually maybe a little joke that's mentioned often in the office. It looks nice on the screen. It's real when a product that you've designed is lying on a table and you can feel, you can touch, you can measure, you can see if it's working. I think that's one of the big surprises and problems in developing a solar boat. Well, time, maybe the only thing in life you can't buy. make things simple, simplify. Also, again, the reason why we've chosen for the T-foil configuration and updating it later on. Then I think the multidisciplinary approach with a team of students working with company partners is very, very good, but also within the team, with people working with different fields of expertise, electronics, boats, composites, making the team work. It's all about communication, knowing what's happening. And I think the multidisciplinary approach is a challenge and opportunity at the same time. So talk a lot, shared lunches, have a beer on Friday evening, all part of the program. Then the C word, Corona, a problem, an opportunity. Well, students like Mick, they work 5 days a week on a project like this. The people from the company, including me, we work on Tuesday evenings on a boat. But when Corona happens, I know Mick is playing basketball, not in Corona period. So we tried to make a safe community, like a bubble, and we worked on the boat on Tuesday evening, Thursday evening, Saturday morning. So actually Corona was an opportunity as well to stick together as a team, to create a bubble and to spend more time on the boat than we normally would do. Mentioned as well, this is a project which is a hybrid community. It's a combination of the company, of students, partners, suppliers. And actually, I have to ask the bookkeeper, but I think we spent about 1,500 euros a year on Chinese food.
Yeah, that's correct.
Every Tuesday evening and Thursday evening. And our budget is about 50,000 euros for a year. And it's 50% the university and 50% the partners that are there on the boat.
Yeah, so regarding testing, we tested, for example, the foils by the strength, and it came out to be 300 kilograms. But we also tested the PCB and the communication systems within our boat. And yeah, this PCB we have in our boat is only 2 centimeters small. But yeah, if you think of reliability, it's not so good, because yesterday it gave us a rough day. So next time we will want to make it bigger so it's more reliable, and yeah.
More sleep.
Yeah.
Okay. Well, about the boat and life cycle assessment, I think many teams are trying to use materials as cleverly as possible. Use scraps, for example, for the relatively small parts that the boat is made out of. We are using in the company a curing device for curing the composites at 80 to 90 degrees, and it only uses 800 watts to cure a box the size of 1.5 by 1.5 meters that is used, for example, for curing the hydrofoils. So very, very low energy consumption, very low. And I think the big chance or the opportunity when you already have built a boat is that not only in terms of efficiency, but also in terms of the euros, the finance. You find the right combination between reusing parts that you have a proven track record that you can use on the boat, but also avoids spending money on things that you already have. So our budget is good, but it's very comfortable when you can reuse the parts from the old boat as well. Okay, well, some of the things already mentioned. At Q Concepts, of course, we are a composite facility. We are developing products based on with the help of materials. Okay, check. And we use the leftover glue, for example. Glue is expensive, is heavy, and we use many of that in the same process as the gluing of the other projects that are glued in the company.
Yeah, so some components we use from our former solar boat are the engine and battery. So by using old components, we could make time to really work on innovations such as modular electronics. So modular electronics was really good because it prepared ourselves for spin-off projects or replacing for easy replacement and debugging. And yeah, by using flexible 3D prints, innovating was more easy. Yeah, so like I said, so for a spin-off project, one example is the solar drone. This is a project I worked on the past 20 weeks. and it's a project that, yeah, it's an unmanned surface craft that is used for data acquisition. And this solar drone uses technologies from the solar boat, but also the other way around. So the solar boat also uses technologies from the solar drone.
Yes, and as a sailboat developer, the lines of the Flow 1, the sailing boat we are marketing throughout Europe, are used also for the solar boat. It has a chine to shed the water, it has buoyancy forward when you fall off the foils so you survive. That's all the technical part. The biggest opportunity we see is that the period is right to capitalize on developments that are done here. Market is made ready. And probably the biggest issue is the human capital. We are here in an environment with engineers, with business developers. There's a podium like this for innovations here in the paddock. Ideas are always there. Engineers, I think, is a big shortage. In Holland, it's a real issue. People fighting for engineers. We want to end this presentation with mentioning that human capital is probably the biggest issue in bringing this technology forward and also to create a more sustainable world.
Thank you, and feel free to ask questions.
In fact, I do have a question, and I have something to say that you have the technical committee of the solar boat that just come to me a few minutes and hours ago, just before taking the flight, and they say me that we really have to thank you and applaud you for all the results you have done, because it looked like you had a difficult year, not that much money, not that much time, and they were very proud about what we have done. So they asked me as a jury chairman to congratulate you for the results that you have done.
Thank you very much.
Thank you.
So now we go back on the technical point. So I understood the process, which is I really enjoy and appreciate. But I am very interested in the technical details, like what kind of solar panel you used, what is the efficiency of your solar panels, what is the efficiency of your engine. I know that you say that it's a double prop propeller, but what exactly it is the efficiency and what is your lag point? This is this kind of detail which we are interested at the jury in order to be able to say this is good, this is not good. We can give you a good grant or not on that point. So it's a sort of question giving you the opportunity to go a bit more on the details that you want, to give us a chance to have a rebound and maybe ask you a bit more detailed question.
Yeah, so about the solar panels, we use custom-made solar panels for the size of the deck. They all only generate around 1800 watt hours in a sunny day. And we use per two panels MPPT, 1 MPPT, so to make a maximum efficiency about the solar panel. We then make use of a motor that's, yeah, depends on the RPM, but it's between 70 and 80% efficient. And yeah, we don't really have the data to tell you the efficiency about the propellers, but I think that's an innovation we need to go to.
Yeah, actually, we are helping other solar boat teams in Holland as well, and especially on the foils. The solar boat team from Twente, not foiling here, but they have a set of foils for their boat. And part of that deal is that we purchase back this double prop propulsion system. So it's a reuse of their old system. And one of the reasons for choosing the double prop system is also to avoid the, I'm not sure if it's English, but the wheel working, the movement that the propeller is bringing into the boat. And you want, of course, do some stable flying, and you want to counter-react that movement. So regarding the efficiency of the propeller, no data yet, but the explanation behind the double prop is, in our case, not only efficiency, but also to avoid the movement in the boat when foiling.
Do we have some questions in the room? Okay, it looks good. Thank you so much, gentlemen.
Applause for
Thank
them.
you. Thank you.
That was Solar Class, and we stay with the Solar Class. I call on the stage AGH Solar Team, please. Applause for them from Poland.
Good afternoon, everyone. My name is my name is Michael, and I'm the technical manager of the team. We are a team based in Poland, and we are under the AGH name, which is the name of our university. It's also one of the top technical universities in Poland. And our team consists of members from 4 sections: the electrical, the mechanical, composites, and marketing. And we divided it in this way just to make it easier for us to work on some problems which are not interdisciplinary, and then we try to combine it into a functioning whole. This year we are really happy to be running with our new boat. This is our 4th time here in Monaco, but the first time with this boat. We finished the construction about a month ago, and we are constantly improving the design because when we first sailed, the boat was in a completely different configuration. So the innovations that we created was to make the hull much lighter. We changed the position of our motor. We also previously were running with a motor integrated into the nacelle, but now we are running a shaft through the entire system and with a dual motor configuration. And right now we are trying to make everything work reliably. When it comes to foiling, this boat was designed with foiling in mind, and we are using 2 control algorithms for that simultaneously, so that we can switch between those 2 and test out which one works better, just for comparison's sake, because previously we were trying to do it with PID, but now we are also trying to integrate neural networks. So we made a model of how the boat should behave, and theoretically it should be better. Now here we couldn't unfortunately foil. During the open sea trials, we damaged one of the components that was responsible for the movement of one of our hydrofoils. So we have 2 movable hydrofoils at the front, and we damaged one of them. We couldn't move the foil at all, and we decided to quickly convert it here to a design without any hydrofoils. We tried using a fixed position of hydrofoils for the speed challenge, because we know that our boat can actually fly in good conditions without any steering, so it's stable dynamically, but unfortunately we just couldn't make it work. The production of the boat was done entirely by us, so our university lent us an old lecture room, and in this old lecture hall we converted into a small production facility. We created the mold ourselves, and here on the picture, on the first picture, you can see us applying the gel coat to our mold, and on the right picture you can see the mold that was created on the left. That is the green part, and the beginning of application of our carbon fiber prepreg fabrics. And the entire hull is created out of carbon fiber prepreg with honeycomb core inside, with some parts where higher strength or different properties were required, utilizing some foam cores, such as PVC foam, also with recycled materials. These parts are, for example, underneath where the skipper sits, because we are expecting some very unusual loads, and we decided that foam core will be better suited for such applications. We had quite a few delays when it comes to our suppliers due to COVID, and the production of this boat was meant to take 1 year, but unfortunately we were hit pretty hard by COVID, and production extended to 2 years, and our budget was about 50,000 euros, which was split from larger part of it was coming from the university, and some of that from our sponsors. Here you can see production of some of our smaller components. In this case, this is a hydrofoil. This hydrofoil was meant as a lower speed, efficient hydrofoil, so we had two in mind, one for flying as fast as possible and one for cruising, so it was more for the endurance race. And one particular kind of weird thing about this foil is that we didn't use a foam core, but we actually integrated some struts into the foam core itself. So for this reason, we needed to machine it 2 times, and then it was only covered with a couple of layers of carbon, and this way we could achieve a much, much lighter foil. And we are actually pretty proud that, and kind of joking about that, even if we lose it because of some structural failure, it's so light that it will float, so we can collect the damage and see what happened. Such pretty extreme optimization of our composite parts meant that we had to do quite a lot of validation testing. So many of the properties of composite components are not really that well documented when it comes to, for example, bonding of some materials. And we were especially concerned about some of our joints where we couldn't just have fibers connected together, and we needed some glue, maybe perhaps some carbon reinforcement on top of that. But after validation, it turned out that actually our core materials are the limiting factor. We are very concerned about the ecological impact that we are making, because we know that some of our technologies that we are working, such as epoxy resins, etc., are not exactly environmentally friendly. So we are really taking into account how much of any component will consume. We are trying to use scraps just like other teams. We actually have separate bins for a different quality of scraps. And also with the stuff that we can't reuse, we try to find responsible recycling facilities that either use it as a filler for concrete, so it's a very high quality filler coming from composite parts, and we are also looking for some companies that are more interested in pyrolysis for the carbon components. We are also very interested in making sure that our components are fixable. So for example, we didn't use any high-tech cooling solutions for our battery system. We used a simple air cooling, and we are also thinking about using some materials that change phase to cool the battery, but we realized that if we were to use them, if one of the sails failed, we wouldn't be able to replace it. And it would mean that we have to spend thousands on a new battery, and also we wouldn't be able to fix it in time. So we decided that going after simple solutions is a better way for us, because we can actually make sure that our systems are fixable and it doesn't make an impact in this way. Our hull was extensively analyzed when it comes to the weight savings, and one of our main approaches when it comes to weight savings was integrating as many parts and mounting points as we could into the hull. And we ended up with a hull that's about 40 kilograms when it comes to mass, and this is with the deck integrated. We are hoping for a bit less, but when we talk to other teams about this mass, we are actually very happy with our results. Only a couple of teams are able to match this result. And we are also very happy about the strength and performance of our hull, because as you could see, the seas were a little bit rough, especially during the endurance challenge. We are very happy that we have no visible damage. And we also saw a bit more extreme tests when we are trying different configurations of foiling, because we could crash pretty hard into the water at higher speeds. A lot of our components, when it comes to electronics, are designed fully by ourselves, and this is not only because the commercial solutions don't fit us better. This is also because we are a student team, and the technologies that we develop can be used in the future in different similar designs. So we figured that it's not a good idea to use existing components that are going to sort of fit our capabilities and what we require, but we are trying to make the best part that might push the future of this component a little bit further. And the same goes for our control system, so we are actually able to control our boat partially from the shore. We can change some settings and also update the software on our boards. The industrialization of this project is quite difficult for us because we are a university project, so I'm sorry for the big slide. It's a lot of information, and we are also actively looking for some partners. We are also co-developing a smaller autonomous vessel that is actually able to do some measurements on different waterways, etc. We are very concerned about the environmental impact, and to be really concerned is we need to measure it. So we need to actually check if someone is polluting somewhere, etc. And we are also looking at the recreational market, because some of our technologies that we develop when it comes to cooling system, when it comes to the power management, can be pretty much directly used in an electric vessel of similar size. Obviously, our boat is a prototype and it's not meant for a comfortable ride, but some of the efficiency gains that we got can be directly applied. Our solar panels are also made entirely by us, so obviously we buy the cells, and these are of the Maxeon Gen 3 variety. We are building them ourselves, partially due to cost reasons. It's very expensive to buy custom panels, and the shape of our hull it requires custom panels, because just a square panel wouldn't fit on our hull. We decided that it wouldn't be much of a problem for us to build cells, but obviously after actually building them, we saw a couple of problems, and we also saw a couple of panels fail here in Monaco. Our nacelle is designed with both dual propeller configuration as well as single propeller configuration. We decided here in Monaco to go with the single propeller configuration because of reliability concerns. We are a bit concerned about the strength of the hubs that we are using. So just before the competition, we actually went through a couple different iterations of the hubs that we had. We are using 3D printed hubs, and the propellers are made out of more or less pure carbon fiber with epoxy resin matrix. And the propellers were analyzed using open source softwares as well as with CFD simulations to validate that they are giving us the expected results. And they also match our testing on the water. We also have got a dual motor configuration, which is meant for efficiency. And I know that it's time to end. And we also cool it with the water that's coming directly out of the sea. So this way we don't have to waste any space on a radiator. We also don't need to use any coolants, etc. It's a pretty efficient design because the water can actually touch the water from the outside. But we had a little bit of issues with leaks with that design. Thank you.
Do you remember any questions?
In fact, I had many questions as Mehdi because I'm very, how do you say, je suis en manque. I need to have more technical details, but maybe we'll ask more if my colleagues have some question in the jury. Okay. In fact, I have 5 questions. First, could you please go back 3 slides before, and thank you for your very nice presentation, a bit too long, but very nice. A bit further, because it looked like you have 2 electric engines on your total, yes, on this one, yes. Could you give us a bit more details about that? Because the first one that integrate this solution was a technical solar boat 3 years ago or 2 years ago, I guess. And it looked like you opt for the same ideas by having 2 engines. Could you give us a bit more details on why you chose this solution and what might be the results you measure by using such a solution?
Of course. So 3 years ago, Technico was using 2 of the same kind of motor. And we looked into their design because obviously we're also looking what the competition does. And we are also kind of running simulation on both the high-speed races and the low-speed races. And we actually discovered that we can get a couple of more percentage of efficiency when it comes to motor if we run the smaller motor on the low power requirement races and the higher power motor on the higher power requirement races. And even we can combine both of them so that we can get more power. Also, we were a bit limited by the manufacturer, so we are using Astra motors, which we are very happy with because of their very high efficiency as well as their robustness. They've got, I don't remember, there's a rare earth metal magnet here, not neodymium, which is a bit more temperature resistant, and that was of a benefit for us because it meant that there's a lower chance that we will damage the motor, and they are quite expensive in that efficiency range. So mainly we are using double motors for the efficiency gains.
And could you please share with the other what kind of engine you use, what kind of power are you, and the gearbox? Will you be able to share that as an open source for the other team?
We are actually obliged under university to share some of our designs in a certain way, and right now we are there's a bit of a change when it comes to how we need to do that, and we need to wait a couple of months before we release any designs.
But it looked like that Technico will help you, and if you can do the same by sharing it in order to help other universities, that will be very good.
Yeah, I mean, obviously we are all for open source design, and we include many of our designs in some publications that our members are doing, but this is done via the university.
Okay, so the other question is in the same way, sorry for that, but it's also important for the others that want to participate in the event. You say that you use a PVC core for the building of your boat. I would like to know what kind of density you use, because I have seen that in many tech talks and no one was giving the correct density, so I need to have the density.
All right, so we used many different densities. There is in particular under the place where the skipper is located, we've got 200 kilograms per cubic meter, yeah. Which is a fairly dense foam. We are also using some PEI foams in some places, but we are having some severe issues with delamination with those. So PVC cores are the most used, and we are also using them in our hydrofoils and the mast structure. And I think the densities range from 60 to about 100 kilograms per cubic meter.
Thank you. And I hope some take the notes, because this is very mandatory for the new construction. And last question that will be important is you all explained that some of the team build their own batteries, and maybe you can go back on the slide where you show the batteries, which in a way is very good, but in another way I am a bit disappointed because I do not see any team that use an hexagonal cells. You all use a cylindric cells, and in my opinion, in order to optimize the power density, that might be one of the solutions. So could you explain me why you are going for cylinders into the batteries and not hexagonal cells?
Okay, so you are talking about the cell shape? Or
yes, cell shape.
So the cell shape is, well, because the way the cells are constructed, so there is a rod inside that's either an anode or a cathode. I'm not sure about the construction, but obviously this is also done by Sony. So these are Murata VTC5 cells. And the way it's just laminated on top of it, it's just that a circular cell comes out of it. So there is also those flat packs, and these are just flat, laminated flat. But I also thought that you might be asking about why are we using like a square configuration of those.
No, I understand that mainly for the integration, but it's an advice for you. I know that you buy, and it's a lot simpler to buy a cylinder cells, but if you look very good, it's now quite easy to buy some hexagonal cells that will help you from the next construction of the battery in the futures.
You see, this actually comes back to the way this is arranged. With hexagonal cells, we wouldn't have any airflow through the pack. So we were concerned that if we pack it too densely, we just wouldn't get the cooling that is required. So actually we could pack it a bit more densely, but we have space on board. It's mainly the weight and the cooling capabilities that we are concerned with.
It's a little point that I think it's also, we are here to make the open source, and this is some information that I have, and I try to share with you that if you have some, hexagonal cells, and you compress all themselves, see if one cells go in extra temperature, then it's cooled by the other one close to it, and in fact the whole cooling system, it will become more efficient than just by having some air in between. So I will be happy if I see next year some students that develop a new batteries, because in my opinion you can save a sort of in between 10 to 20% efficiency on the power density in such batteries. It's okay?
I have a last question on your battery. What about sealing and water? Because you are putting airflow directly inside of the battery, so you don't have any safety issues.
Could you repeat the beginning?
You have direct airflow coming into the battery.
Yes.
Do you have any safety issue?
So actually, this is the battery is mounted inside of a closed electronics compartment, which is then again closed by some structural members inside our boat. There's airflow coming into our electrical system, but it's also filtered from the water via a U-shaped water collector. It's similar to oil collector in a cars, but much simpler and designed for water. And we didn't have any issues when it comes to cooling with that.
Okay, thanks.
So I think we do not have questions anymore, and congratulations, because we were a bit pushy with you and you were quite good. Thank you.
Thank you so much.
Thanks again, and here we go for the last tech talk. I call on stage SBM Offshore E-Racing Team. Monaco team, call on the stage. And please keep in your mind that you have 7 minutes, not more, before the jury questions. Thanks.
Yeah, good evening, everyone. So we are the last one to present. We will try to make it short, but please allow me two words. The first one for the Yacht Club of Monaco and all the organization for the event itself, but also for giving the opportunity to companies like us, SBM Offshore, to exchange and meet universities and future clever engineers. The second, congratulations to Uniboat team who wins our energy class. Yeah. So, e-racing team from SBM Offshore, we are a team of around 20 persons coming from Monaco, Fontvieille, from our laboratory in Carros close to Nice, and also a few members coming from Schiedam in Netherlands. You can read here, by the way, the vision of our company, which is entitled in our strategy for a few years, and can directly acknowledge that it is perfectly in line with the energy boat challenge. With regards to the project and the conception method, starting with the sustainable development goals, we wanted to put in front streams like innovation, sustainability, circularity, modularity, safety, and efficiency and performance. As you can see on the picture, we got a brilliant inspirator, and we wanted indeed to stick as much as possible to green and full autonomous boat. And I think it is open source, huh? Yeah. Indeed, our project is based on green hydrogen, on PEM fuel cell, hybrided, sorry, missing words here, don't know why. So hybrided with solar panels and thermoelectrical generators that generate the heat, that convert the heat generated by the fuel cell into electricity. We use as well recycling, repurposing, and upcycling materials, you will see later on, with battery, a standard propeller, and telemetry. So here you can see that in fact we have two projects in one, a pontoon which deliver the green hydrogen for our boat, and the boat itself. And here, what I like here is that basically starting from the pontoon, we have the propeller of a windmill plus water, and at the end we retrieve the water released by the fuel cell, which make also rotate the propeller of the engine. So we have a virtual circle here as well. And my wife says sometimes that I'm a little bit too romantic, but I like the picture of saying that we have a boat propelled by hydrogen sustainably produced from the same water on which it navigates. Just a few words about the pontoon. We have a capacity of delivery of 1 liter per minute. This is a prototype. We hope to make a better in the next years. And the capacity of filling bottles up to 200 bars. I will not go in detail. This is open source here as well. With regards to the boat, we will add a few details after. Actually, we did not encounter too much difficulties during the development, but we encountered difficulties during the last 2 days. Actually, when we arrived, we lost our telemetry system. That never happened during the last few months, so we were completely blind. We did not know how much capacity we had in the batteries, how much bars was remaining in the bottles, and so on. And we also, as lesson learned, our company actually is specialized in mooring system and is not used to make navigate vessel on the water. And here, actually, we missed some propulsion experience. So this is what we have to improve for next year. We, as lesson learned also, our fuel cell could be better cooled. And you know, mentioned very quickly, we have a thermoelectrical generator that transform the heat generated by the fuel cell into electricity. If we improve that cooling, we will also improve the energy we will be able to retrieve from the fuel cell. And as a big company, safety first, safety first, safety first. So be aware that we have, for instance, 3 H2 sensors on our boat. And if we miss one connection, actually we miss the boat because it stops everything. As lesson learned also more globally, in a big company, when you have a change, when you have a problem, there is, I will say, not huge, but I will say huge procedure, management of change, and so on. And here on the spot, you need to be reactive. And actually, we are not so reactive as the student that you can see on the paddock. This is also a lesson learned. Testing and results for the hydrogen generator. So watertight testing for sure. We produced the first H2 molecules in February, and the pontoon was fully commissioned a few weeks ago, just before coming here in our lab in Carros, in collaboration with our team in Sridham. For the boat itself, actually we made a promising trial test end of May. We reached the speed of 14 knots, okay? What we did not manage to do these last 2 days. And what was missing, actually, we put a test bench, but we did not have the counter resistance to push the engine to and the fuel cell to the limit. What was missing? So we had a fuel cell of 3 kilowatts, solar panels of 400 watts, and the thermoelectrical generator were able to produce a few hundred watts for a standard motor of 4 kilowatts. Here, I don't know, you don't have the figure, but we run a life cycle assessment, and basically we compared our boat with a standard boat combustion engine of 6 horses power. And basically, thanks to the green hydrogen, the emission of CO2 is reduced by 90%. Then I will give the floor, I will pass the floor to Kevin, who is a little bit the father of the thermoelectrical generator, to explain a little bit how it works.
Okay, so for the thermoelectrical generator this year, we put it again on the boat. And we understood more things about it. We arrived to generate some volts, but not enough to put it in the system directly. So we know now that we need a higher delta of temperature to put it in the system, like solar panel production. So this year we only powered a screen with the voltage that we create during the race. So normally we can see it on the telemetry system, which doesn't work this year, but we have the part from the fuel cell, the photovoltaic system, and the thermoelectrical generator, and to see the ratio between what the fuel cell is giving to the engine against what is completed by the batteries. When we need more power, the battery compensates or deliver what the engine needs.
And well, it was not the last one. Also, with regards to eco-conception, perhaps you will have seen that our boat is very simple. Actually, we take the ladder of a mason, we put on the carbon beam, then we take a laundry basket, we put inside the fuel cell, and we wanted to show that being simple, with a little bit of innovation, we can be performant. We were not so performant as expected, but we will come back next year. And the last but not the least, what next? So with regard to the pontoon, we can dream in a few years about green hydrogen provided thanks to the electricity provided by wind farm. Okay. And with regard to the boat itself, I was happy actually to see that it's not a dream anymore, but for our company as well, using the hydrogen produced by the same wind farm to transport our crew for maintenance and installation and so on. Thank you. If you have questions, we want time.
Perfect. Congratulations. Applause for you, Kurt.
Yes, I have to say merci beaucoup and congratulations for what you have done and achieved, because also it's, as you say, open source, and for a company sharing some solution like this as an open source, it's rare enough to be highlighted. So congratulations for that first step. And also to anticipate the evolutions that we had in mind when we spoke about it with Florestan and Charlotte, because our idea in the future was to oblige the team to produce their own energy on site. And before we put it in the regulation, you already did it. And thank you for that, because this is where we want to go. I guess the technical question maybe when you say we lost the telemetry and we did not achieve the speed that we were expecting, could you share a bit what was, let's say, the mistake? And if you will come back next year, what will be the evolution your target by sharing with your other team, other students, and maybe also with a solar boat, because they have a very efficient draft, and that might be a very good advice for you, I guess.
Yes, so as mentioned, we have a lot of improvement to do on the propulsion, because we are not at all efficient. You can see a lot of waves and splash behind our, so we will work on that. Then we had some CAN issues, losing the connection between the batteries and the fuel cell and so on, and everything was not talking to each other.
A sort of CM mistake.
Of
un champ électromagnétique, CEM.
Perhaps.
Yeah.
That
was highlighted by the technical expert. Huh?
Yeah. We will dismount next week and open it and share with you. Yeah.
Perfect. And if I understand right, all the developments that you have done so far will be accessible as an open source. And where you're gonna share it? You're gonna share it on a website, on a Facebook page, on.
It has already been shared. We also send a full technical dossier to the organization on the pontoon as well. So it has already been shared. Then afterwards,
so the yacht
as agreed.
Yeah, so the Yacht Club of Monaco can offer to anyone that wants to upload all the developments that you shared with the Yacht Club so far.
Yeah.
Perfect. Thank you and congratulations for that.
Thank you to you.
No more questions. Thanks a lot, SBM. Congratulations. You can put it. No, don't worry. But at the end of the Tech Talks, thanks again, thanks to the jury members. And now we have still work. keep working for you to remember until 8
Yes.
p.m. for the prize giving. And yes, you have a meeting room now. Thanks again. See you in 1 hour. Prize giving at 8. Thanks a lot. Don't be late to the teams. Meeting at 8.